Hey gang, Mr. Cruze here with another Algebra 2 review for you. This time, the Semester 2 Final Exam Review. Insert ominous music here, alright? This is it. This is the end of Algebra 2, basically. In this video, we're going to try and do as many of the review questions as we can. There are 57 total on the entire review, and we don't want this to last 12 and a half videos, so let's try and get as much of it done in one video as we can, okay? Due to spacing between the problems, I may have to erase some of my work at certain points, okay? Try to follow along, alright? If at any time you have any questions, you can email me, you can tweet me, I suppose. You can come in early for extra help, whatever it takes for you to do well on this test, alright? So, let's go. Find all the real square roots of negative 1 over 121. Well, normally, when you take the square root of a number, you could have plus or minus whatever the square root of that number is. Well, that'd be fine if it was positive 1 over 121, but when I try to take the square root of a negative, I get an imaginary answer, and we want the real square roots. So there are no real roots for this. Whenever you try to take the square root of a negative, you get no real roots. They're only imaginaries, all right? Number 2, simplify the quotient. So basically we're going to be reducing here. Since these are both under cubed roots, we can actually go ahead and reduce things and make our life a little easier beforehand. You can treat them just like they would be if they weren't inside radicals. So 162 divided by 3, I think works out nice. Yeah, it's 54. Y to the 5th over y squared. Well, two of them are going to cancel, so you're going to be left with y to the 3rd. And there's nothing on bottom. That all goes away. So now I just have to take the cubed root of all this, right? Well, you may remember we have to break down our cubed roots into perfect cubes and not perfect cubes. 54, if I look at my list of perfect cubes, breaks into 27 two times. And y to the 3rd, well, that is a perfect cube in itself, and there's no extra y's left over. So you take the cubed root of 27, which is 3, and the cubed root of y cubed is y. And then, of course, we have that lame cubed root of 2 just sitting around doing nothing, all right? So there it is, 3y cubed root of 2. Reduce, break down your radical, and go from there, all right? Number 3, rationalize the denominator of the expression, square root of x over the square root of 2. We can't leave square roots in the bottom of fractions, so we have to multiply by whatever it takes to make it a perfect square so that it no longer has a radical. Well, I currently have a 2 to the 1st power. I need 2 of each, right, because this is a square root, to get out of the square root. So I need another 2. And whatever I do to the bottom, I must do to the top. So on the top, we get square root of 2x. On the bottom, we get square root of 2 times 2, which is 4. So you get square root of 2x over 2. And I know it's tempting to want to cancel those 2's, but you can't. One is inside a square root and it's kind of shielded, if you will. The other's not. It's footloose and fancy-free down there. So square root of 2x divided by 2 is it. A rectangular stained glass window has length 15 square root of 2 inches and width 10 square root of 2 inches. So let me draw a rectangular stained glass window. Length 15 square root of 2, width 10 square root of 2. What's the perimeter? Hopefully you remember how to find perimeter. You add up all the sides, right? Basically, when you add radicals, it's kind of like adding x. It's really no different than 10x and 15x and all that. So the square root of 2 is going to be on there, of course. But you just take 10 plus 15 plus 10 plus 15. Let's see, so it'd be 30, 40, 50 square root of 2 inches. Basically, just add them all up. Number 5, converting these into radical form. Well, you might remember the denominator of your fraction is what's called the index of your radical, right? So the 7 goes there. And then the numerator is just the power of whatever that base is. So this will be x to the 3/7. It's the 7th root of x to the 3rd. This one we can do very similarly, only we might have to convert negative 3.5 into a fraction form. You can check me on this if you don't believe me. It's negative 3.5. You multiply these two and then add that 1, so you get negative 7 over 2. You can check me. Does that equal negative 3.5? You bet it does. So we're actually converting, I'll circle that one so we don't get confused. We're actually converting y to the negative 7/2 into a radical. Well, it'd be the square root. We don't have to write the index of 2. It's just understood if we don't write it that it's 2. y to the negative 7th. Well, I can't let that live the way it is, so I'm going to put 1 over the square root of y to the 7th. We can't have negative exponents. Technically, we can't leave radicals like this, but it's radical form. They didn't want us to do anything more. Okay? Now, let's go backwards. Number 6. Square root of a to the 5th. Well, the power of a goes on top. The index goes on bottom. Well, they didn't write an index, so it must be 2. So that's a to the 5 halves. And this one is, of course, b to the 3 over 5 power. Hopefully you can see that through my red ink from before, right? 5 is the index, so that's what goes on bottom. So there's your 2 answers, okay? As you can see, a lot of these don't take a lot of time to calculate. They just take a little bit of time to explain, okay? Simplify 3 to the 1/3 times 9 to the 1/3. Okay. As long as they have the same powers, I can kind of do a distributive property of sorts with the powers. I can kind of factor out the 1/3 power, and it's kind of factoring out. And then I'm just left with 3 times 9, which is 27 to the 1/3. You can go ahead and plug that in your calculator. 27 to the 1/3 ends up being 3 exactly. So that one worked out quite nicely. So let's continue on. Let's try number 8. Solve the square root of x plus 2 minus 2 equals 0. Well, first things first, let's go ahead and add this 2. That won't be so bad. Square root of x plus 2 equals 2. And then, how do I undo a square root? Well, if I take the square root of 4, I get 2. And then to undo that, I would square it again, right? So let's square both sides. Obviously here, the square root and the square root are going to cancel. So you're left with x plus 2 equals 2 squared, which is 4. And then this all of a sudden looks like more of an Algebra 1 equation that you can solve. You subtract 2, and you get x equals 2. You can always, at any time, check this answer back in your original. Square root of 2 plus 2, which would be 4, minus 2. Well, 2 minus 2 does equal 0, so it does work out. Especially since part of your final is multiple choice, you could always check your answers very easily. A spherical tank holds 9,000 cubic feet of water. What is the radius of the tank? Well, volume, they give you the formula, 4/3 pi times the radius cubed. This happens to equal v, right? So I'm going to replace v with 9,000, and that equals 4/3 pi times the radius cubed. And we're going to find the radius. First things first, I'm going to multiply both sides by 3/4. Obviously, whatever I do to one side, I have to do the other. Why 3/4, you ask? Well, because that'll cancel out the 4/3. On the left, 3/4 of 9,000 is 6,750, and that equals pi r cubed. Well, what else do I have to get rid of before I can get r by itself? Now I have to divide by pi. You can use the pi button on your calculator, or you can use 3.14. For simplicity's sake, I'm going to use 3.14, just in case you don't have a calculator with pi on it. I get 2149 we'll go a couple places, 68 equals r cubed. How do I undo cubing something? Well, it's similar to how we undid square root. Now I'm going to cube root to undo the cubing. So it'll be the cubed root of that really large number, 2149.68. Hopefully you remember how to type that on your calculator. If not, you can always take that number to the 1/3 power. That is also cubed root. You should get roughly 12.91. Maybe if you go 12.9, and this is feet, of course. Don't forget your units. Okay. Basically, if you can plug the radius back in and pretty much get the volume, then you've got it. All right. Number 10. Let f of x equal 2x squared plus x minus 3. And g of x equal x minus 1, so find f minus g. So we're basically just going to take 2x squared plus x minus 3 and subtract x minus 1. And this may seem simple enough, but there's one little catch. This minus sign is going to catch a lot of people, this minus sign right here. I almost suggest doing this. Change this to plus, but if I'm going to change this to plus, I have to change the signs of everything after. So that means this becomes negative x, and this becomes positive 1. For some reason, addition seems to work better in people's minds, so let's add across now. I have 2x squared, has nothing to combine with. I have a plus x and a plus a negative x. Well, x minus x is 0x. There's no x there at all. So negative 3 plus 1 is negative 2. So it's 2x squared minus 2. You just have to combine your like terms. Again, the biggest thing you have to be careful of is the minus. Think about distributing that negative 1 through, okay? Be very careful on the negatives. Number 11, let f of x equal x squared and g of x equal x minus 3. Find f of g of negative 2. Here's how I do this. I do g of negative 2 first. So I'm going to plug in negative 2 into g. Negative 2 minus 3 equals negative 5. So that's my answer. I'm going to take this answer now and plug it into f. You always do the one that's closest to the number first, and then you plug that answer into the other one. So now I'm going to do f of negative 5. Be very careful to get your parentheses in there. When you square a negative 5, you get a positive 25, and that's your answer. Okay. Number 12, find the inverse of y equals 3x squared minus 5. Real simple to find the inverse. You switch the x and y. So x now becomes y and vice versa. And now we just have to get y by itself. So I'm going to add 5 to both sides. I'm going to go ahead and divide by 3. I'm not even going to worry about making those separate fractions. The last thing I have to do to get y by itself is take the square root. And of course, when I take my own square root, I have to remember that it could be the positive or the negative root, right? So I have to have that plus or minus in there. Otherwise, we're in trouble. Well, there it is. There's the inverse. Plus or minus the square root of x plus 5 over 3. Is it a function? Well, here's what's going to happen when if I were to graph this. I would end up with a sideways parabola, which would definitely fail the vertical line test at a lot of points, right? So is it a function? No, it's not a function. In general, the ones we're dealing with, okay, whenever you have the plus or minus, you're going to have an upper branch and a lower branch. It is not going to be a function with the plus or minus, all right? I think that'll do it for this video. At least we did the first page. All right, in the next video, we will continue on, all right? If you ever have any questions about this final exam review, please, please, please come in and ask for help. Not just from me. There are plenty of other teachers that are willing to help you as well, all right? We want you to do well on this final. It is 20% of your semester grade, all right? Good luck studying, and I will see you later.